What does Pythagoras Theorem have to do with circle geometry? Let me tell you, it's a whole lot, especially when you are solving problems with a powerful chord bisector theorem, right? In fact, question 2 is a wonderful question that involves radius of circle, right? So I would love you to pay attention in this video. Welcome to Post Scholars channel. I hope you are having a great day. Now let's dive in. We have two questions we are going to solve in this video. This is the first question and this is the second question. Now let's start with the first question. The first question says a chord of a circle is 12 cm long. The radius of the circle is 10 cm. Calculate distance of the midpoint of the chord from the center of the circle. Now before I solve this question, I would like us to understand the concept of chord bisector theorem. Now what does chord bisector theorem says? It says when you have a circle, right, with a center, right, and you also have a chord. By now you should know what a chord is, right? Now the theorem says a line that bisects this chord, right, into two equal parts subtend an angle of 90 degrees with the chord. By now you should know that a small square represents 90 degrees. So that's basically what the chord bisector theorem is talking about. So with this information, we should be able to solve this question. Now let's solve. The question says a chord of a circle is 12 cm long. Now let's draw the chord, right? This is the chord and the length is what? 12 cm, right? Now the radius of the circle is 10 cm, right? Since the radius is 10 cm, we need the center. This is the center, and the radius is a line that touches the center and any part of the circumference. So let's choose this one. Good, right? Now this is the radius. We are told that the dimension is what? 10 cm. The question now says calculate the distance of the midpoint of the chord from the center of the circle. So from here, from this point to the midpoint of the chord, and from chord bisector theorem, the angle here will be what? 90 degrees, and this side will be equal to what? This side. Remember, from here, from this point to this point, the whole of the chord is what? 12 cm. Therefore, from here to here alone will be what? The half of 12, which is what? 6 cm. Now what we will do now is we are going to extract this triangle out of the circle so it will be visible for us. Now let's extract it. We have something like this, right? Now this is the extracted triangle where this part is 10 cm, right? This part is 6 cm. Take notes, we are just taking this part, right? While this side is unknown, with this angle being what? 90 degrees, right? Now this makes this triangle a right angled triangle, right? Since this is what we are looking for, we can label it X. Now this leads us to a theorem called Pythagoras Theorem. It's equal to what? Opposite square, I shortened it, plus adjacent square. You should have heard of this before. Let me emphasize it with red. Now this is a theorem called Pythagoras Theorem, right? Where from this triangle, the longest side is always the what? Hypotenuse. Take note of that. The longest side is the hypotenuse, right? This side is the opposite and this side is the what? Adjacent, right? Now let's substitute. It says hypotenuse squared. What's the hypotenuse? 10. So we represent as 10 squared is equal to, what's the opposite? Unknown. So let's take that as x squared, right? Then plus, what's the adjacent? The adjacent is 6. That's 6 what? Squared. 6 squared, right? Now let's expand. 10 squared is the same as what? 100. That's 10 times 10. Then x squared plus what? 6 squared gives what? 36, right? Now what do you need to do? Subtract 36 from both sides so that to isolate x squared. So when you do that, you have 100 minus 36 equal x squared. And when you do the subtraction, you have 64 is equal to x squared. Let's rearrange it so that it looks pleasant to the eyes. X squared equals 64. Remember, we need to find the value of x, not x squared. So to do that, you take the square root of both sides. And when you do that, square roots and square roots. So these square roots cancel squared. So what's left? We are left with what? X. x is now equals to square root of 64 is what? 8 centimeter, right? So we have gotten the value of the distance between the center and the what? Midpoint of the chord to be what? 8 centimeter. I hope it is well understood. Now let's move on to question 2. Okay, this is question 2. Please pay attention as we solve this question step by step. Without wasting much time, let's start. Question 2 says an isosceles triangle ABC has its vertices on a circle. So what do? Let's draw a circle first of all. Now this is a circle, perfecto, right? Now the question says an isosceles triangle ABC has its vertices on a circle. So let's draw the triangle in the circle. So like this. Okay, let's start with here. Okay, we want to draw the triangle in the circle, inscribed in the circle, right? Good. The question says an isosceles triangle ABC has its vertices on a circle. So let's label the triangle. By now you should know what a vertex is. A vertex is the point where two or more sides meet. So this is a vertex, this is a vertex, and this is a vertex. Now let's label this point ABC. So we have point A, point B, and point C. Now the question says if line AB or side AB is equal to 13 centimeter. So AB 13 centimeter. So let's label it 13 centimeter, right? BC is also what? 13 centimeter. This is BC 13 centimeter, and AC 10 centimeter. So AC is what? 10 centimeter. The question now says calculate the height BM of the triangle. So the question has given us an hint that BM, M will be the midpoint of what? AC, the midpoint of AC. Because we know that this is an isosceles triangle, this side and this side are what? Equal. So let's label this point M. So we are looking for side BM. So let's use a broken line to represent it. BM. This is point M, right? Now looking at this, without even using the chord bisector theorem, we instinctively know that since from here to here is 10 centimeter, automatically from here to here is going to be what? 5 centimeter. So label it as what? 5, right? 5 centimeter. And this side is also what? 5, right? So to find BM, we need this part of the what? Triangle. So let's extract this part of the triangle. When we do that, we have something like this, right? This side is 90 degree. You should know by now. This side is 5 centimeter and this side is 13 centimeter, right? Then this side is B, this side is point A, and this side is point M. What I did was I just extracted this part of the triangle, right? Now, if you look at this again, you see that it's depicting a right angle triangle. So we still need to use the concept of what? Pythagoras theorem to solve this. And what does Pythagoras theorem says? It says hypotenuse square HYP square is equal to opposite square plus adjacent square. Now what's the hypotenuse square? The longest side, which is what? 13 square, plus what's the opposite? The opposite is BM, right? BM. So we label it as BM squared plus what? What's the adjacent? The adjacent is what? 5. So plus 5 squared. Now let's simplify. Take note, this one is supposed to be 13 squared equal to, not plus. This is supposed to be equal to. So let's change it. Now 13 squared give 169 equals to BM squared plus 25, right? So we subtract 25 from both sides. When we do that, we have 169 minus 25 equal to BM squared. Then 169 minus 25 gives 144, right? Equal to BM squared, right? Let's rearrange. When we rearrange, we have BM squared equals 144. All I did was interchange. Now we need to find BM. Look at the question. The question says calculate the height BM of the triangle, right? So this is height BM, which is represented as this. So we don't need BM squared. What we need to find is BM. So to eliminate this squared, you take the square root of both sides. And when you do that, you have square root and square root. So this square root cancel squared. What's left? BM is now equal to root 144. And if you press your calculator, the square root of 144 gives 12 centimeter. Now we have gotten the value, the answer to question A at BM. At BM is 12 centimeter, right? Now, this is where it gets interesting. The next question says, find the radius of the circle to the nearest whole centimeter. So we come back to this diagram. Okay, let's duplicate this diagram. Now, here's the diagram. We were asked to find the what? The radius. You can see it. The radius of the circle. So coming to this diagram, where is the radius of the circle? For you to locate the radius of the circle, you must first of all locate the center. So this is the center of the circle. This is the center of the circle, right? So the radius is the line touching the center and any parts of this circumference. So let's choose here, right? Good. So this is R. Now, this radius is called circumradius. Take note, R is equal to circumradius. Why? Because we have a polygon, which is a triangle, that is inscribed inside a circle. There's an automatic formula for finding circumradius, right? And the formula is given by ABC, that is the multiplication, over 4 times area of triangle. So there's nothing you can do. You need to put this formula in your head. The formula helps you to find the radius of a circumcircle. You understand? The radius of a circumcircle. If a polygon is within a circle, to find the radius, right, you need this formula given as ABC over 4 times area of the triangle, right? Now, let's solve this quickly. Without wasting much time, R is equal to, what is A? A represents the sides of the triangle. And what are the sides? 13 centimeter, 13 centimeter, and 10 centimeter, right? The whole of this place is 10 centimeter, right? So becomes A is 13 times 13 times 10 over the denominator now 4, right? Times area of triangle. You come back here. What's the area of a triangle? If you remember, the area of a triangle is half base times height. If you remember vividly, the area of a triangle, let me write it here. Area of triangle is equal to half base times height. This is a very popular formula. I hope you've not forgotten. If you have forgotten, type in the comments that I forgot to know. But now you know. So the area of a triangle is half base times height, right? So we represent the first one, half times, what's the base? Look at the triangle. This is the triangle, right? This is the triangle. Take note, the base is like the bottom of the triangle. So what's the dimension of the bottom of the triangle? Dimension is what? 10. So you just say times 10 times, this is half base times height. What's the height of the triangle? If you remember, the height of the triangle is BM, which we have gotten to be what? 12 centimeter. So you just represent it here as what? 12 centimeter. Now let's continue. R, which is the radius, is now equal to, if you do the multiplication of 13, 13, and 10, you have 1690. You can confirm with your calculator. 690 over, let's do this, 2 here 1, 2 in 4 is 2, then 2 times 10, 20, then 20 times 12, that's 240. So the denominator gives 240, right? So we have R is equal to 1690 divided by 240 gives 7.04. You can use your calculator, but always follow instruction. Instruction says calculate the radius of the circle to the nearest whole centimeter, right? To the nearest whole centimeter. So to the nearest whole centimeter, the radius is approximately 7 centimeter to the nearest whole. As simple as ABC, right? So this is the final answer. Good. Now we have come to the end of this video. I hope it is well understood. If you actually understand everything concerning what we did, what we have done, please type in the comment that it is well understood. I wish to see you in my next video. God bless you and bye.